The universe is the most extraordinary chemical laboratory imaginable. For 13.8 billion years, it has been running an immense experiment, transforming two simple initial ingredients into everything we see around us today. From the farthest galaxy to the precious gold in a wedding ring, every atom tells a cosmic story. This grand cosmic kitchen started with remarkable simplicity. Understanding this journey from basic ingredients to incredible complexity unveils the fundamental processes that built our world. It reveals how the universe literally forged the elements of life. Our universe began in an incredibly hot and dense state, which rapidly expanded and cooled. In those very first moments, the universe was too energetic for stable atoms to form. Only fundamental particles existed. As it expanded and cooled further, conditions became right for the very first atomic nuclei to emerge. These were primarily hydrogen, with a smaller but significant amount of helium. Tiny traces of lithium and beryllium were also created. This early universe was a remarkably simple place chemically. Imagine a vast, almost empty void, primarily filled with hydrogen and helium gas. All the incredible diversity of elements we know today had yet to be created. Gravity began its tireless work, slowly pulling together the diffuse clouds of hydrogen and helium gas. Over millions of years, these colossal clouds collapsed under their own weight. As they grew denser and hotter, something spectacular happened in their cores. The immense pressure and temperature ignited nuclear fusion. This was the birth of the first stars, the universe's initial set of chemical furnaces. These pioneer stars were far more massive and burned much hotter than our sun. Inside their fiery hearts, hydrogen atoms fused together to create helium. This process released colossal amounts of energy, which is why stars shine so brightly. It was the first step in the universe's grand elemental alchemy. As these massive first-generation stars exhausted their core hydrogen fuel, they began to change. Their cores contracted and heated even further, igniting new fusion reactions. Helium atoms started fusing together. This process created heavier elements like carbon and oxygen. Depending on the star's mass, this stellar nucleosynthesis continued in concentric shells. Each layer fused lighter elements into progressively heavier ones. These stellar cores became sophisticated element factories. They produced neon, magnesium, silicon, and sulfur. This relentless process continued, building elements higher and higher up the periodic table, right up to iron. Iron represents a critical turning point in stellar nucleosynthesis. Fusing elements lighter than iron releases energy, powering the star. However, fusing iron into heavier elements actually requires energy rather than releasing it. Once a massive star's core is predominantly iron, it faces an energy crisis. It can no longer generate the outward pressure needed to counteract the inward pull of gravity. The core collapses catastrophically. This rapid collapse triggers an immense explosion known as a supernova. For a brief time, a supernova can outshine an entire galaxy. But more importantly, it's during this violent cataclysm that the universe's heaviest elements are forged. The extreme temperatures and pressures unleashed during a supernova explosion are unparalleled. In these fleeting moments, vast amounts of energy are available. This energy drives fusion reactions that create elements heavier than iron. Elements like gold, silver, uranium, and platinum are born in these fiery stellar deaths. They are not merely created, they are also violently ejected outwards. These elements are scattered across vast cosmic distances. These massive explosions act as cosmic recyclers, enriching the interstellar medium with new, heavier elements. Without supernovae, the universe would remain a chemically simple place. We literally owe our existence to them. Recent astronomical discoveries have revealed another dramatic source of heavy elements. When two incredibly dense neutron stars spiral inward and collide, they create a phenomenon known as a kilonova. These spectacular mergers are even more energetic than many supernovae. The extreme conditions within a kilonova create an abundance of the very heaviest elements, like gold and platinum. These events are cosmic treasure chests. Just as with supernovae, these kilonova events spray these newly formed heavy elements out into space. This enriches the cosmic gas clouds even further, providing the raw materials for future generations of stars and planets. The elements forged in the hearts of stars and scattered by their explosive deaths don't just drift aimlessly. They become part of the vast interstellar clouds of gas and dust. These clouds are the nurseries for new stars. Our own solar system formed from such an enriched cloud of cosmic material. This cloud contained hydrogen and helium from the Big Bang, along with carbon, oxygen, iron, gold, and all the other elements forged by previous generations of stars. The Sun condensed from this material, and the planets, including Earth, coalesced from the remaining dust and gas. Every atom in our planet, every atom in our bodies, has a stellar lineage. We are truly made of stardust. Consider the oxygen you breathe, the carbon in your DNA, and the calcium in your bones. These atoms were all manufactured in the fiery hearts of ancient stars that lived and died billions of years ago. The iron in your blood, vital for carrying oxygen, was cooked in the core of a massive star. The tiny traces of iodine in your thyroid or copper in your enzymes also have similar cosmic origins. Even the gold in your wedding ring, that symbol of enduring love, began its journey in the heart of a dying star, or the collision of neutron stars. It traveled across unimaginable cosmic distances to become part of our world. The universe is not static. It is a dynamic, evolving chemical laboratory. From those initial two simple ingredients, it has meticulously built the intricate periodic table of elements. This process continues today, within stars across the cosmos. Every time we look up at the night sky, we are gazing at countless stellar furnaces, actively engaged in creating the building blocks of new worlds and potential life. The journey from hydrogen and helium to humanity is a testament to the power of cosmic chemistry. It is a story of immense beauty and destructive power, of creation and recycling, spanning billions of years. And it's a story that reminds us that we are intimately connected to the grand, ongoing chemical experiment of the universe.